Hey guys, this is Carrie, and this is the answer key to homework number 2. So for problem number 1, I made a correction on your page. So it let f of x equal 2 square root of 3x minus 5. Identify your answer as a rational number, irrational number, or not a number. If your answer is an irrational number, make sure it appears in simplest radical form. So just like we did in the do now, I think the best approach to solving this problem is to subdivide the allotted space into 3 regions. So let's look at part A first. Determine the value of f of 7. So because f of x is equal to 2 root 3x minus 5, f of 7 means substitute 7 in for x. So 7 is our input, 3 times 7 minus 5. F of 7 is equal to, and now we just have to evaluate things. 3 times 7 is 21. 21 minus 5, sorry, that's not distributing. 21 minus 5 is 16, so we get 2 square root of 16. F of 7 is 2 square root of 16, and we're lucky here. The square root of 16, because 16 is a perfect square, is just 4, and we end up with 2 times 4. And so we get f of 7 is equal to 8. For part B, we're instructed to find, and I'm just going to give myself some extra room here. For part B, we're instructed to find f of 11. So f of 11 means we're inputting 11 for x. That's equal to 2 square root of 3 times 11 minus 5. F of 11 is equal to 2 times square root of, putting it all together, 28. Square root of 28, 28 is not a perfect square, so we have to use a factor tree to break down 28 into 4 and 7, which becomes 2 times 2 times 7. So f of 11 is equal to 2 square root of 2 times 2 times 7. Now that we've broken this down into prime factors, we're trying to find twins, and we've got a pair of 2 2's, so 1 2 is going to escape, 1 2 dies, and we get f of 11 is equal to the 2 that escaped times this 2 is 4 root 7. And then finally for part C, which we'll do in green, determine the value of f of 1. F of 1 is equal to 2 times root 3 times 1 minus 5. F of 1 is equal to 2 times root negative 2, evaluating the whole interior. And of course, if we tried to do the square root of negative 2 on our calculator, we'll get a non-real answer because we can't find the square root of a negative. So this actually, f of 1 has no answer. Okay, so it looks like I missed a key part of this problem. I hope you guys caught that before I did. I'm supposed to be classifying these answers. So for part A, we have a rational number. And with rational numbers, you always want to think about ratios of nice numbers. We can write 8, the final answer is 8 over 1, which would be a ratio, a fraction, with an integer numerator and denominator. So this is a rational number. 4 root 7, because we have the square root of 7, this will be an infinitely long, non-repeating decimal, an irrational number. There's no nice fraction representation of this number. And then finally here, this is not a real number, as I think I already wrote, but for some reason I am writing again. All right, let's take a look at problem 2. So in problem 2, we're asked to simplify the square root below completely. So we've got 40, and just like we did in class, I actually usually like to save the number till the end. So I want to look ahead to the x to the 10th. So if you think about x to the 10th, I've got a whole bunch of x's, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. And we're not going to be doing this, obviously, for y and z, as those powers are too high. But I think it's helpful to see. So when we write our x's out like this, we're thinking, well, how many pairs of x's do I have? So I've got 5 pairs of 2. 5 times 2 gives me 10, so that looks good. And from each of those pairs, the first one will get out, and the second one will die. So half of the x's get out. Half of the x's die, and so I'm left with x to the 5th. Now thinking about y to the 800, the exact same thing is going to happen. We'll end up with 400 pairs, since 400 times 2 is 800. Half of them will get out, y to the 400th. Half of them will die. For z to the 1000th, half of them get out, half of them die, so there are no z's left. And finally, I have root 40. Just like we talked about in class today, square root of 40 is not the final answer, right? This part can actually be simplified by using a factor tree. So let's break down root 40. So 40 can be broken down into 5 and 8s, 8 into 2 and 4, 4 into 2 and 2. So we get root 5 times 2 times 2 times 2. We're looking for twins here. We've got a pair of 2's. So 1, 2 will get out, 1, 2 will die. So putting things together, this 2 that comes out right here, that's going to be the lead coefficient of our expression. We've got x to the 5th, y to the 400, z to the 500. And then when we took the square root of 40 off to the side here, it looks like 5 times 2 is left in the square root, so we have square root of 10. This probably wasn't my best way to show work. I probably didn't have to do this part as an aside. I should have probably kept it in context with the problem, but I think it's clear. This is a really key point from our Do Now today that I wanted to review. So this is something that confused me all through high school. Square root of 36 is just a single number. It's just 6. However, when you solve the equation x squared equals 36, because we have a power of 2 here, we're expecting 2 answers. In order to find those answers, we take the square root of both sides. We get x equals 6 or x equals negative 6. So the point of confusion for me was telling when I had a single solution and when I had 2 solutions. This is a single answer because square root of 36 is just a number. This is 2 solutions because the 2 means that it will have 2 solutions. So whenever you start with an x squared, you'll end up with that number 2 solutions. So for problem 4 here, we've got to solve the equation. So you got 50 minus x squared equals x. I'm going to square both sides to get rid of the square root. That gives us 50 minus x squared equals x squared. We'll add x squared to both sides. 50 is equal to x squared plus x squared is 2x squared. Divide by 2 on both sides. X squared is equal to 25. Finally, to isolate x, we take the square root. And because we started off with the power of 2 here, we're expecting 2 solutions. We get x equals 5 and x equals negative 5. Now you might think we're done with the problem and put your answers in a box, but square roots are dangerous. So you may end up with a mad fake or extraneous solution, so we need to validate our answers. So in order to validate them, let's see, x equals 5. Let's check it first. So we get the square root of 50 minus 5 squared equals 5. This becomes the square root of 50 minus 25 equals 5. 50 minus 25 is 25. And the square root of 25 is 5, so x equals 5 is the solution. Next, we need to check our green solution. So we have to validate both of them. X equals negative 5. So we get the square root of x equal, or sorry, that's totally wrong. The square root of 50 minus negative 5 squared. And we want to see if that equals, we have to plug in negative 5 for both x's here, equals negative 5. Negative 5 squared, negative 5 times negative 5 is 25. So 50 minus 25 equals negative 5. This again gives me the square root of 25 equals negative 5. But that's not true because the square root of 25 is 5. So this ends up being false, which means that this is an extraneous solution. So we actually end up with only one answer to this problem, and that's the highlighted in yellow answer right here. All right, next up we've got if f of x is equal to this crazy square root, for what value of a does f of a equal a? So what this says to me is when I input a in, the output is a. So just labeling these things. So it's a little bit of a hard mathematical statement to translate, but now in the start step that we've got it translated, we can actually just solve for a using the standard tools available. So let's square both sides to cancel out the square root. That gives us a squared minus 4a minus 8 equals a squared. It looks like we've got a squareds on both sides of the equal sign, so maybe I'll subtract a squared from both sides. These cancel out, and that gives me negative 4a minus 8 equals, well, here we have the same thing. A squared minus a squared is 0. So now from this step, let me just rewrite it so that it's clear. We can add 4a to both sides. We get negative 8 is equal to 4a. We divide by 4 on both sides. We get a equals negative, not negative 4, a equals negative 2. And you might be tempted to put that answer in a box, but the thing we have to check here is we have to validate our answer, right? Because square roots, we said in class square roots are dangerous, right? Because we looked at the member of the Pythagorean cult that was killed, right? So square roots being dangerous means that we have to validate or check our solutions. So I'm going to check this answer right here. I'm going to go back to the original equation that we had to check it. So we get negative 2 squared minus 4 times negative 2 minus 8. And I'm wondering if when I square root that all, it will equal negative 2. Nope, I'm running out of room. Sorry, if it will equal negative 2. So let's see, we get negative 2 squared is 4, minus 8 equals negative 2. Sorry, this one, negative times negative, I made a mistake, it's plus 8, right? So combined, these are 0. So you get 4 plus 0 is the square root of 4, and we're wondering, does that equal negative 2? But the square root of 4 is 2, not negative 2. And so negative 2 fails our check. So there's actually, we had one possible answer. Because that answer fails our check, this is actually not a solution. So there is no solution for this problem. Alright, for problem 6, we have a throwback question. It says, consider the function f of x equals the square root of x plus 5 over 3, and we're trying to find f inverse of x. So we have a nice step-by-step procedure to do this, right? So what we'll do is we'll write our steps as we execute them. So steps. Step 1, replace f of x with y. So our equation will become y equals, oh actually I'm going to stick with blue for now, and then I'll change to pink later. So you'll see y. Y equals the square root of x plus 5 over 3. So this is still the same function as the original function. So now in order to get the inverse, we have to switch the input and output. So we have to switch x and y. So now when we switch x and y, I'm going to switch to pink because now this has become a different function. It's now the inverse. So we get x equals the square root of y plus 5 over 3. This inverse function that we just wrote looks a little strange because we haven't isolated the y. So the next step is going to be to isolate y. So now in order to isolate y, we'll have to multiply by 3 on both sides. That cancels division by 3. We get 3x is equal to square root of y plus 5. We square both sides to eliminate the square root. I also made sure to put parentheses here because when I square both sides, I have to square the whole side. So 3x squared is 3 squared is 9, x squared is x squared. That equals y plus 5 on this side. And the final step to isolate y is minus 5 on both sides. And that leaves me with y isolated equals 9x squared minus 5. The final step, in order to find the inverse, is we made up this variable y, so we need to change y to f inverse of x. So the final answer for our problem, just a change of notation, f inverse of x is equal to 9x squared minus 5. I know that sometimes it cuts off the end of my videos, so now